Hello and welcome to today's video. In today's video, I'm going to be showing you how we can create a time and date and year and season system. Great for farming games, obviously inspired by Stardew Valley. I'm going to be covering the C# programming of the system, and then also how we can have stuff displaying on our UI. And as well as you can see that as it gets towards night, the sort of scene gets darker in the background. I'll go over that as well. And you can see that the system includes like the day, the date, the year, the season, the week we're in, the time. And we've got this nice dial as well that kind of shows us exactly where we are on the day. We're going to be using structs, enums, animation curves. There's quite a lot to get stuck into here, so let's just get straight into it. I'll quickly go over the scene. Let's just clear those out. So I've got my camera. I've got a script called a weather manager, time manager. This is where most of the magic happens. And then we have I've got the scene, which is just the grid, the sort of tiles in the background. And then we've got our canvas, which obviously has got our clock on it. So the main thing is this script, the time manager script. I'm just going to go through this sort of step by step. Okay, so the main bulk of the class is in this time manager script. So we've got our date and time settings, so we can choose which date in the month we want it to be. We can choose which season we want it to be. We could choose the year and the hour and the minutes. Okay, so then we've got a private date time, which is a struct that I've created, and this allows us to store the current date and time and also do some like manipulation of the date and time. And then I've got a thing here called tick settings, and this is just going to control how fast our clock moves along. And then I've got a static unity action, which is going to pass over the date time, and this is just going to say on date time change. So every time it ticks, the date's going to change, and we're going to want to alert anything that wants to care about the date to that change. For example, our interface, every time the date changes, it receives this unity action and it updates the clock accordingly. And I'll show that a bit later on in the video as well. So just to kind of show how I'm using this date time, I've got some debugs here. So first of all, a date time, new date time. So this is just like a struct is like a vector 3. So when you do vector 3, like pos for position, you'd say new vector 3, and then you'd pass in like the x, y, and z. Okay, so date time is our own sort of struct, just like a vector 3 is a struct. So I'm creating a new one, and I'm going to pass in what day in the month it is, which season I want it to be. And now the seasons kind of in the back end are 0 to 3 because it's index based of 0 to 3. So I'm just going to minus 1 from the season we put here. I capped this range 1 to 4 just because that's a bit more sort of readable, user-friendly in the editor. So 1 would be spring, the first season, sorry. 4 is winter, the fourth season. But the actual math is spring is 0 in the back end, and I'll get to that later on as well. And just with other structs, we can have functions on them. So I can say datetime dot, and then I can get whatever date New Year's Day is in year 2. I can get the summer solstice in year 4, the pumpkin harvest in year 10, and then I can also get what the date of the start of the season is, or when the start of winter is. Theoretically, like I know that it's the first of, it'd be Monday the 1st of winter would be the kind of season, but you can also see that we've got total days and total weeks counting, which take into account the year. So New Year's Day of year 2 would be Monday the 1st, it'd be spring, 113 total days would have passed, and 17 weeks would have passed by that point as well. And we'll see that the pumpkin harvest is the 28th of autumn, summer solstice is the 28th of summer, the start of the season, so the start of summer is on Monday the 1st, and in year 3 that'll occur on day 253. So we can do quite a lot of complex stuff with structs. And the reason we're doing a struct, because obviously we could program all of this into our time manager class, but the reason that we've put it as a struct is that we can then pass this like through events, for example. So I can pass the date and time to anything else that needs to know about it. So at start, I'm just going to call date time to set it to whatever we've set the date and time to be, so the clock's correct. In update, we're just running through our tick. And then on tick, we're going to advance our time. And the main way that advancing time is done is we're going to advance the minutes of the time. And I've got tick seconds increase here. which is set to 10. So every time it ticks, it's going to increase the time by 10 seconds. We could increase it by 5, 20, 30, like it's completely up to you what you want to put in there. And because with advanced time, we're just going to say that the time has changed and invoke our onDateTimeChanged event and pass in the current date and time. So let's just close this class down. And let's have a look at our datetime struct. So you can see that we've got quite a lot going on here. We've got some fields, properties, a constructor, the time advancement methods, etc. And I'll go through them. So in our fields, we've got a lot of private ints because we don't actually want to manipulate the date and time anywhere else. We just want to be able to advance time in our time manager and then have all of the math sort of happen behind the scenes. So we've got private days, which is an enum, and season, which is also an enum. And this is just so we can assign a string to a value quite easily. Then we've got private int date. So this is 1, 2, 3, all the way through to 28. Year, it's quite self-explanatory. Hours and minutes, again, self-explanatory. And then we're keeping track of the total number of days that have passed and the total number of weeks that have passed. And this could be quite handy. So in your game, you may want to have an event happen on day 100, like it's a big day, so you can check when date and time is advanced. If a total number of days is equal to 100, then you can, trigger your cutscene or whatever it is that you want to do. So they're our fields. In our properties, we're just returning all of those as getters, so we can't actually set them elsewhere other than in here. Using this symbol here, this is the same as saying public date public int date get return date. Obviously that's calling up an error because we've already got something called date. So we could do that, or we could just use the expression body definition. So let's just get rid of that. And we're doing that for all of our, hour, minute, season, year, total number of days, total number of weeks, and the current week. We have to have a bit of math here in place, so you just use the modulus operator. So the total number of weeks, the remainder from 16 gives us the week in the year. So for example, if we're currently in week 17, which is week 1 of the second year, that's week 1 of the second year. However, if we are on week 16, it returns 0. So we just need to check for that, and then it is going to be 16 of that year. And that's the same that if it's week 32, it returns 0, but it'd actually be week 16 of the year. So we just need to do that bit of math there to kind of catch that. And then we've got our constructor. So here we're setting the day to whatever the date we've passed in is, modulo 7. So if we pass in day 4, for example, so if the date is the 4th, well, it's going to be the 4th day. So if it's day 8, for example, if we've put it's the 8th of the month or the season in Stardew Valley terms, it's going to return 1, which is day 1, which is a Monday. And this works all the way up. So if we do 27, it's going to return 6, which is a Saturday. And just like with the total number of weeks, we need to catch whether it's a 0, because if 28 modulo 7 returns 0, which is a Sunday. So for that one instance, we need to set it to Sunday. And then we're going to set the date to the date that we've passed in. And with some of these, you may want to clamp them because I've put these ranges on and I'm controlling it from the inspector, I know it can't go above 28. But you might want to just catch that out in case you're making a new date time from somewhere else. You may want to say that if date is above 29, you're going to set it to 1, for example, just to kind of clamp that. Because obviously in our system, there is no day 29. And then we're going to set the season to the season, year to year, hour, minutes, blah, blah, blah. And then we've got a bit more kind of tricky math here. Well, it's not too tricky, but for me, I'm not great at math. I was quite proud that I've got this to work. So our total number of days, and the reason that we have to calculate this is we may put in, like you saw earlier, we're making a new date time and we're calling it, and it's going to be in the 3rd year of the 4th season. It's day 28. So how many days have passed to get to that point? So we're casting our season enum to an integer, which just to show you this so it makes sense. So spring is has a value of 0, summer's got a value of 1, autumn 2, winter 3. So if our season, which we're casting to an int, so if our season is spring, this will be 0. If it's summer, it'll be 1. And we'll go with 1, for example. So we need to check first which season we're in. So if we're season 0, then we know that the date, it can't be higher than 28. So we'll just return 28. But if it is, so if the season's passed and the date is reset to 1, but we're in the next season, we need to return the date plus 28, which is the number of days in a month, times by the season we're in. So again, just to kind of show that kind of working. So if season is 1, so if we're in summer in our enum case, if it's greater than 1, so if this returns 1 and it's greater than 1 and that's true, then we need to return the date. So if I've put in a date of, it's day 15 of summer, and then to that we need to add 28, which is the days in the month, times by whatever season it actually is. So, if it's season 3, 99 days will have passed. There's 112 days in a Stardew Valley year, in a year in this instance. So we do 28 plus 28 times 3, so 112. And again, so 3 is winter. This is the final season. And if we pass in 0, then, 28 days have passed. Which actually, that makes that, we can just simplify that to this. That's a lot easier to look at, isn't it? Let's just check that's working. Yeah, that's working. All of our dates have stayed the same. See, math's not my forte, but we've discovered something together. But then, because we need to take into account the year as well. So here, I was doing the same thing. Realistically, now I know that we can do that. We can just get rid of this. So here we've got total number of days is equal to the total number of days plus 112, which is how many days there are in a year, times by a year minus 1. The reason we're minusing 1 from this is if we're in year 1, that we don't want to add 112 to it. So for example, if we're in year 2, we minus 1 to that and then we'll add 112 days. I hope this is all making sense. So let's just go through that again. So if the total number of days is, 88, and then we're in year 2, so we're going to add to that 112, which is the amount of days in the year, times by our year. So we're in year 3, for example, and we minus 1, so that'd be 2. And then we can just get this back. So that'll actually be 3. The total number of days will actually be 312, taking into account the year. And you know what? We can simplify it even further by adding that to this. And then, so there we go. That's our calculation to figure out how many days are in a year. So the total number of weeks is going to be 1 plus the total number of days divided by 7. So weeks that have passed, so if there's been 88 days, divided by 7, plus 1, it'll be 13. So 13 weeks have passed. It'll be 13 and a half weeks. So that's how total number of weeks works. So that's our constructor. So then we come to our time advancement section. So we're going to call in advanced minutes here, and we're going to pass in the seconds that we want to advance by. So all we're saying here is if minutes plus the seconds to advance by is greater than or equal to 60, so we need to get the remainder of what's left after we go over to the hour, and then we want to set our minutes to that, and then we want to advance to the next hour. And obviously if we don't go over 60 and hit that minute mark, then we just want to add the seconds to advance by to our minutes. Before we advance the hour, we're checking whether that would hit 24, because if it does, then it's a new day, because we've gone over the 24th hour. So we're going to set hour back to 0. Thinking about a 24-hour clock, we go from 23:59, and as soon as it hits 24, it goes to 00. So then we're going to reset the hour to 0 and advance our day. And if it doesn't do that, then we're just going to advance the hour like we want to. And then when we advance the day, we're going to check whether that day would take us into a new week. If it does, we're going to set the day. Day in this case is Monday, Tuesday, Wednesday, Thursday, Friday. It's not the date, which we do separately down here. So if if increasing the day would mean that we've gone past Sunday, then we need to go back to Monday and we're going to increase our total number of weeks. And if it doesn't do that, then we're fine to just increase the day as normal. And then regardless that we're going to increase the date, and if that date, mod 29 equals 0, then we know it's a new month or a season in Stardew Valley time. So we're going to progress to the next season and we're going to set our date back to 1, because obviously we don't want to set it back to 0 because day 0 doesn't happen. And then regardless of all that, we've got total number of days, that's just going to tick up. And actually, we can simplify that. Let's just have day plus plus up here and then check the day. So we're going to advance the day regardless, but if it goes over this threshold, then we're going to reset it back to what it should be. And then the same with date, and we're going to increase the total number of days. When we advance the season, if the season is currently winter and we're requesting the next season, then we're going to go back to spring and we're going to advance a year. And if it's not, then we're just going to go to the next season. And then advance year, we're going to set the date back to 1 because obviously it's the first day of the year, and then we're just going to increase the year. So that's how the actual time advancement works. Hopefully that all made sense. I know that was slightly math heavy. Math's not my strong point, but I think I've got it down. Let's just close that. So before I go on to the kind of methods that I've got here, let's just check out our enums. So I've already shown season. So we've got spring is 0, summer's 1, autumn's 2, winter's 3. I did something different in days to have them kind of aligning specifically where we want them to. I put in a null at 0, but because of the systems in place, we're never going to hit 0. This just makes it a bit more user-friendly because you know the 7th day of the week is a Sunday, or Sunday could be the first day of the week. It depends how you manage your calendar. In England, Monday is usually the first day of the week, so this is how I've arranged it for myself. If you're confused about the numbers and enums and how that's working, the documentation kind of goes over this here. I covered this in a previous video, so I won't read it back out here, but I will include a link to this page in the description below, because there's some good information on it about how enums work and how they're kind of just ints under the hood. That's how it allows us to cast season from the actual string that we've put in to an integer. Okay, so then we've got some Boolean checks. So here, these are custom things. You could change them for your game. So is night, I'm saying if it's after 6 p.m. or before 6 a.m, then yep, it's nighttime. And then I want to check whether it's morning. So if it's greater than 6 a.m. but less than 12 p.m, then it's probably morning, so we can return true. Is afternoon, so if it's after midday but it's before 6 p.m, it's the afternoon. We can check whether it's a weekend. So if the day is greater than Friday, then it's the weekend, so we can return true, else we'll do false. And then we can check for a particular day as well. So is particular day, we can pass in day.Friday. And if it's Friday, this will return true. If it's not Friday, it'll return false. So that's just some different bool checks that we can do. And this is the powerful kind of nature of structs that you can do these kind of things. Some key dates that I've got. So here I've put in some key dates, which you saw at the start. So if I call New Year's Day and pass in a year, it's just going to return the date in that year at time of 6 a.m, which is kind of when a day would start. Summer solstice is the same, so it's the 28th of spring. Summer. We've got pumpkin harvest, which is the 28th of autumn in the year that we pass in, and again it's 6 a.m. So there's some key dates that I've kind of outlined. We've got some start of seasons that we can check for. So we can check whether it's the start of spring, start of summer, start of autumn, start of winter. So this is returning a date time. These could easily be bools as well. You could check whether a date that you pass in matches this date. That's something you could do. You could add that to your Boolean checks. And then I've got some toStrings as well. So this is specifically so it kind of formats to how my clock is set up in the kind of user interface. But the first thing I do is I'm overriding the normal sort of like built-in toString method. So you could say like vector3.1.toString. So here you could say string, v3 is equal to vector3.1.toString. So you can override this toString method. So when you call toString, it's just going to do whatever you want it to do itself. So here we're saying that the date is the date to string, what season it is, what time it is, where we don't actually need the toString because we're not doing anything different with that. Here we're returning the date to the string and the time to the string, which are two other kind of toStrings that I've put in here. So I'm just going to return the day, the date, and a year with a leading 0, with some spaces between them for the date. With time toString, we need to do a bit of foolery here to kind of convert from a 12-hour, to convert it from the 24-hour clock to an AM/PM clock. So I've just made an int called adjusted hour. So if the hour equals 0, then we're going to replace that with 12, because it'll be 12 AM when it's 0 in a 24-hour clock. We do else if hour equals 24. So again, in a 24-hour clock, we can adjust the hour is equal to 12. And if it's greater than 13, then we're just going to minus 12 from that. Thinking about it, again, we could get rid of this one. That should work. Let's just check that, make sure I'm not leading you astray. Yeah, so that's at 12 AM, so that's fine. We've cut the code, slimmed it down slightly there. So if the hour is above 13, then we're just going to return the hour minus 12 to convert it back to its normal thing. And if it doesn't match any of them, we're just going to return the current hour it is. And I've got a string called AM/PM, and this is equal to whether if hour equals 0 or hour is less than 12, then it's AM. So it's the morning. And if it's not either of those, then it's the evening, so it's PM. And then we can return our adjusted hour.toString with a leading 0, our minutes toString with a leading 0, and then whatever the AM or PM is. So that's how this clock works. That's the under the hood sort of like date and time system. So here we can increase the time by 20 seconds or 30 seconds. We can control the time between the ticks, so we can go a bit faster. So this is every 0.5 seconds, we're advancing time by 30 seconds. Hang on, this is minutes increased. I am a fool. I just need to rename this. This is a tick minutes increase, not seconds. Tick minutes increased. So we're going to say here that, every 60 seconds, we're going to increase the time by 1 minute. We've made a real clock. Obviously, that's boring for gameplay. You may not want that. You might want that if it's like an Animal Crossing type thing where time progresses in real time. Then obviously, you might want minutes to go by between every 60 seconds. But I'm just going to put mine back to 0.5 and we'll increase by 30. Just so we can see that kind of happening. So every half a second, we're increasing our minutes by 30. We can increase this, to 60. So we can jump an hour every 0.5 seconds. And you can see that we're carrying over the kind of minutes and it's looping back around. And we can start in any date, season, year, hour, or minutes. So I'll quickly show you the clock kind of function, like how this is working and how it's using the date time to progress time on the actual UI. Okay, so that's the time manager done. Let's go over to our clock manager, which is controlling the UI. It's controlling this clock here. So we've got a reference to our clock face, which is the dial with the sun and moon on it. We've got a reference to the text, which is for the date, the time, the season, and the week. We've got an image for our weather sprite and an array of sprites to choose from for the weather that we pick. We've got a float for our starting rotation for our clock face, which we need to kind of calculate the rotation. And then we've got our sunlight with its night intensity, day intensity, and then we've got a day-night curve which controls which we're going to use in the lerp between the night and the day intensity. So on awake, we're just going to set our starting rotation to the clock face's local Z rotation. And then we're going to subscribe to our onDateTime changed event. And we're going to pass in the date time to our update time function here. I don't need this. This was from something else. Okay, so in our update date time function, we're going to set the date to the date to string text that we've got, which was this, if you remember. Day, date, year with some spaces in between them with a leading 0 on the year. Time text, which is our date time to string, which again is this. So So it's our adjusted hour method that we made. I'm going to call toString on the current season as well. Again, so our season is either going to be spring, summer, autumn, or winter. And if we call toString, it's going to return the strings. Our week text is going to return the current week. We don't need this is telling us we don't need the toString because it'll convert an int to a string anyway. It's going to be week, whatever the current week is. And then we're going to set the weather sprite to whatever the current weather of the weather sprite is. I'm not going to cover the weather manager. I'll put a link up here to a video I've already done on a weather manager, which kind of goes into a lot more detail about how the weather system could work in this. And then we need to get a t value for our lerp. And again, I have a video on lerps, which I'll put up in the wherever it'll come up. So we're going to lerp our rotation between 0 and 360 using the t value. We're going to set our clock face to this new rotation, offset by its starting rotation. So we don't actually have to line it up on the canvas. We could just do that through code here. But this is the kind of more interesting bit, at least for me. So we've got an animation curve, which is our day-night curve, and we're going to evaluate our passing in our t value. So we're going to get the time of day, and we're going to evaluate a curve and get another t value for another lerp called the day-night t. And then we're just going to set our sunlight's intensity between our night intensity and our day intensity. So if I go over to our clock, which is where I've got this clock manager script, you can see I've got a reference to our sunlight here, which is, it's controlling how bright the sprites are. So if I go over to our clock, we've got our night intensity, which is 0.2, day intensity is 1. So this is day kind of behind us now. And then we have a day-night curve, which if we open up in the curve editor, how animation curves work are we can define a curve and we can give these sort of any sort of value. So you can see this goes from 0 to 1, and it could go from 0 to 10, it could go from 0 to 100. They're really powerful things. But because we're using it to get a t value, which is between 0 and 1, I've got my range here at 0 to 1. So the way this works is we were passing in the t value of where we are in the day. So if we were at midday, our t value here, so this t value here, if we were at midday, this would return 0.5, and then we're going to evaluate our curve at t, which would be 0.5. So if we look at our curve window, you can see that it's 0.5 on the timeline. This is the t that we're passing in. So at midday, it will be 0. So we're going to pass in our midday, and it's going to be 0 night. There's going to be like no night influence is kind of what this is saying. If our t value was sort of 0.25, it'd be kind of halfway to noon, which is where the sun's going to be its brightest. And then the closer we get to either midnight at 0 or midnight at 24, then it's going to be dark. So here, if I hit play and then we bring up our curve again, you see that we started at 12:30 p.m. So we started at full brightness. And as we approach nighttime, the light's going to get dimmer. It's going to go up the curve. Once we get to 12 a.m., it's going to go back, and then it's going to start to go down the curve. So this is controlling kind of how much daylight we have in a day. But the great thing about these curves is we could have multiple curves. So we could have a curve for summer. We could check if the season was summer, then we'll go for a different curve as well. And summer might be, so now this could be our summer curve. So it's going to have a really short night, and then it's going to be full brightness all day because it's summer. Let's see that in action. So we're pretending it's summer, the time's going along, and we'll see that as it gets to sort of nighttime, it's going to start to get dark now. So we've got a longer period. Conversely, in winter, for example, you could have shorter days and longer nights, so we could bring that in. Start getting dark from 3 o'clock. Currently in England, that's about right. It starts getting really dark at 3, and then it just gets darker as it goes into the evening. We'll go over to a new day of year 62, and as we approach kind of the midday, it'll be at its brightest, but then it's going to go down again. So you can have lots of different kind of types of curves here. I'm just going to reset this back. So midday is going to be 0 darkness. So this is a nice kind of curve. But yeah, you could have here this animation curve. You could have multiple ones. You could have a spring, summer, autumn, and winter curve. And then here, when you are evaluating the day-night curve, you could say that if datetime.season is equal to season season.summer, then you'd say evaluate the summer curve. For example, that's how that would work. Let's just get rid of all this. That DP util stuff is just because I've got it in a namespace, so I can put it into my the utility package. So yeah, I mean that's kind of it. That's the kind of basis of it. You know, this time manager is quite a simple script in the grand scheme of things. So it's broken down quite well, I feel. You know, we've got our two enums. When I originally kind of made a prototype for this, I had months as well. So I had a, I had a months enum, so you could have longer. I've been playing a lot of Stardew Valley recently, and in that they have, there's not 12 months in a year because that would be a really long farm year. There's 28 days in a season, and there's 4 seasons in a year. So that's how that works in Stardew Valley. So that's what I've replicated here. But you could expand this. You could have a months variable, and then, as you advance the days, you advance the weeks. Then after that, after 4 weeks have passed, you advance the month. So you could make a fully working kind of clock with that. But in terms of gameplay purposes, this way of doing things, I feel, is better. That's why I like Stardew Valley and Harvest Moon, those kind of games. They don't have 365 days in a game year. Certainly not in real time. Yeah, I hope that all made sense. I feel like this is going to be quite a long video. If you want me to cover anything else about this system, or want some clarity on some stuff, do let me know in the comments below. If you want to get the project files for this, including the graphics of the clock, not the ones in the background, unfortunately, they're not mine. But I kind of designed this clock myself, so if you want the project files, including the sprites, to put into your own game, the project files for that will be over on Patreon, which is linked in the description below. If this video was helpful, I'd really appreciate a like and maybe consider subscribing to see future videos from myself. But if not, no worries. Hopefully I'll catch you in the next one. See you later. Bye.